Hi, my name is Adam Osman, and I will be talking about my project, Design of a Metabolic Analog to Inhibit SARS-CoV-2 Cellular Entry. First, an overview of the problem. As we all know, we are in the middle of the COVID-19 pandemic caused by the SARS-CoV-2 virus. Since it was first discovered in December 2019, over 140 million individuals have been infected, and there have been over 3 million deaths as a result of infection. In order to prevent the spread of the virus, governments have been forced to order stringent measures such as lockdowns, social distancing orders, and mask mandates, causing great social turmoil. However, despite these measures, the virus continues to spread. In December 2020, the US began the distribution of newly developed COVID vaccines, and as of April 20th, 2021, over 210 million doses have been administered, and nearly a quarter of the US population is now fully vaccinated. However, the long-term efficacy of the vaccines is currently unknown due to their rapid development time, and it is also unknown how well the vaccines will work against new, future strains of COVID-19, creating the need for other methods to prevent infection by the virus. In fact, both Pfizer and Moderna announced that individuals will most likely need an extra booster shot in the future for their vaccines, and they may even become yearly vaccinations similar to the flu vaccine. What I am working on is an alternative method of preventing infection by the virus that can be used as a protective measure during vaccine development cycles. To understand how my solution works, we have to understand how the COVID virus infects us. The first step of infection by SARS-CoV-2 is cellular entry. In order to infect the cell, the virus uses what is known as the spike protein to attach to the ACE2 receptor present on the outer cell surface, as shown in the figure on the right. Once attached to ACE2, the virus is able to enter the cell and infect it. However, in order to reach the ACE2 receptor, the virus first binds to what's known as a lipid raft on the outside of the cell. So, first the virus binds to the lipid raft, where it can then access the ACE2 receptor which it binds to, and finally it infects the cell. The solution I am working on involves preventing the virus from attaching to the lipid raft on the cell's surface. The specific molecule which the spike protein attaches to is known as sialic acid, which is shown on the bottom left. We believe that if we can modify the sialic acid molecule to have a longer carbon chain, as shown here, using what's known as metabolic glycoengineering, it would no longer fit into the virus's spike protein, much like how two incorrect puzzle pieces can't fit together. I am working on designing a molecule that would allow for this modified sialic acid to be incorporated into cellular receptors, preventing infection by the SARS-CoV-2 virus. Using this technology, we aim to develop a new method of preventing infection by COVID-19, and in the future, this method could also be applied to other infectious coronaviruses. Thank you for listening.